morning, everyone. My name is Alhassan Kabore. I'm a software engineering student at Ghana Communication Technology University. To continue with the assignments, firstly, I would like to explain what we are doing here. As you can see on the screen, this is a digital logic circuit that performs different logic operations like AND gate, OR gate, and exclusive OR. It is a kind of things you will use inside a CPU, specifically inside an ALU, that's arithmetic logic unit, which is the part of the processor that does all the calculation in the computer. So the goal of this circuit is to take in a set of binary inputs and run different logic operation on them. There is a different logic operation on them, but instead of doing just one phase operation, it can switch between different ones. That's why it uses a multiplexer. So then the multiplexer here choose which results should send out based on some control input. Like you see, this is a logic gate, the AND gate. So based on the input, if I select 0, it choose which results to send out. So that's the function of the multiplexer. So this is like a logic section of a full ALU. If I add adder or subtractor to it, we are going to get ALU. Our ALU is going to work for us. So I want us to continue from here. So we want to add subtractor and decoder to find out whether our ALU, because our project is that we want to build ALU, that's arithmetic logic unit. So we want to add subtractor and decoder to see whether we will have a working ALU.
So let us look for our subtractor. So we go to yes, we go to arithmetic and then we pick our subtractor. So we are picking our subtractor and we know what the subtractor is going to do for us. So in ALU, that's arithmetic logic unit, the subtractor is going to do difference of two input variable. So it's going to do subtraction in binary form. So we will join the subtractor to the third input. Let's assume that the third input is C and the first input is A and the second input is B. So the ALU is going to join the subtractor is going to join the third input, and it also join the first input. Yes, you see. So we are going to join also the second input. We are going to join the second input. So as you can see, this is the subtractor. We are building a half ALU. So when we add adder to it, it means that we are gradually building a full ALU. So right now we are concentrating on how we can add we are adding subtractor and decoder in ALU. So let us push. We want to construct, let the line touches the output, the second output. So we want to push the logic gate forward so that we will get enough space there so that we can pass the line through that particular area. So let's join this. Yes. So let us, yes, move forward a bit. Let us move it for a bit. So now let us try to see whether our line can pass through very well. Yes. So now we're able to draw the line to touches the second input. So what's the next step? The next step is that we have to get logic, that's we have to get LD matrix. So the LD matrix here, what it's going to do for us is that the LD matrix is accepting, so the LD matrix here, you see there is, we have, when you say matrix, we know what comes in mind. So we have to set the property to 0 0. The column should be 0, the rows should be also be what, 0, as you can see on the screen. So let's try to join the subtractor to the lead matrix. But when you are doing, you have to take your time. If not, you are going to mess up the line. Able to join it. So what's the next steps? The next step is that we have to go and pick a decoder. To go and pick our decoder. So we go to the plexer, we pick our decoder. So let us put it here. Okay. So now we have to change the property. Yes, to make let's put it no. Yes, that's the include enable to be no. And then what's next? We have to delete this input, so that we want to join it to the multiplexer. We want to join the decoder to the multiplexer. Yes, so next we have to also, after finishing this, we have to also join the the decoder to touches the subtractor. So that's what we are doing. We want to build a half ALU. So our next meeting, we can able to build full ALU that is going to perform arithmetic logic unit. So let's join the decoder to the subtractor. Now we're able to join. So you see, now we are able to join the decoder and the subtractor and the multiplexer. So let's text for, boom, you see, now we are able to test for everything. You see that the decoder is working, the multiplexer is also working, and the subtractor is also working. As you can see, we are testing to see everything is working. Everything is working. We have made it. You see, let us test. You see, when you go to the exclusive OR gate, you will see that it turns green. Yes, it tells you that the decoder is working, everything is working. If there's something wrong, it's going to be like the lines, some of the lines going to turn orange. So far as the lines, there's no lines that turns orange. It tells you that everything, the circuit is working. Everything is working in the circuit. So now we are able to build a half ALU. So our next meeting, we are going to build a full ALU. So as you can see on the screen, everything, that's what, when when you see your CPU, the CPU, inside the CPU, this what is going on. It perform arithmetic logic units, perform arithmetic and logic unit in the computer. So as you can see, everything is working, everything is working, everything is working. If you put it at logic 0, you will see what happens. At logic 1, you see what happens. It tells you that everything is working. Thank you. We shall meet